Welcome to the sessions on basics of Matlab. So we'll continue our discussion. So in our last discussion, we have concluded that whatever we create, whatever variable you create, it will be treated as matrix or vector. That's what we concluded. And then we discussed different data types that were supported by this Matlab and different kind of operations that can be performed on these variables, like arithmetic operations, relational operations, bitwise, logical, all kind of operations can be performed, and I have listed out all those operations. Now, so we'll move a little bit from these variables. Now what we discuss is how to create these vectors, how to create matrices. These things we'll discuss now. So let us continue our discussion with vectors now. So now, if you want to create a vector, we can create it in Matlab simply. There is no need to define the data type again. You can simply write A equals to list of items, list of elements, 1, 2, 3, 4, 5, enclosed in these square brackets, and simply press enter. So it will create a vector for you. Now if you see here, this workspace A was already created. What is its size? Its size is 1 by 5. That means what we created? We created a row vector, right? Now the question is how to create a column vector. So in order to create a column vector, we use the semicolon. So this is the other use of semicolon. The first use of semicolon we have already discussed. In order to suppress the output, we use semicolon. The other use is to what? To separate the statements, right? So that it will inform the interpreter that these are two separate numbers or separate statements like this. 1 semicolon 2 semicolon 3 semicolon 4 semicolon 5. Now let me create it. Now you see, earlier the display was like row vector, you see. Now the display was like column vector. The same thing can be verified in this workspace. Now you see, if you open B, the size of B is 5 by 1. Now you see, you can see the values in a vector format, in a column vector format. Whereas if you open value A, you see it was like a row vector format. So this is the difference between creating a row vector and creating a column vector, right? So we were able to create this row vector and column vector. Now suppose you want to access elements, right? We have created element, this vector, row vector or column vector. Now you want to access individual element of this row vector or column vector. That you can simply do by simply using the index within these brackets. Simply write the index. Suppose you want to access the third element, you write A3. What is A of 3? 3. So this will tell you that the index in Matlab starts from 1. Unlike other programming languages like C or Python, wherein the index starts with 0. But here in Matlab, the index starts with 3. This you have to remember. This much you have to remember, right? Now, in addition to this indexing, you can access some range of elements within this vector. So that is called slicing, or you can access a part of the vector in Matlab. How to access a part of the vector? It is also simple. It is simple. You write the indexes. Let us say you want to access the elements starting at second index and up to fourth index. You simply write 2 and 4. They are separated. They should be separated by this column. A of 2, 2, 4 will give you the elements from 2 to 4. Elements at index 2, index 3 and index 4. Are we clear? So this way we can access part of the vector also. Now we have created vectors, a row vector, a column vector. We are able to access individual elements. We are able to access a range of elements, right? Now let me discuss few more things before discussing operations that can be performed on these vectors. Now let us say you want to access all the elements starting at 2 till the last element. Now if you want to access all the elements from 2 to last element, that means you have to know the size of the array. If you know that the size of the array is 5, then you can write that 2 to 5. Okay, this is good. This way you can access the elements from 2 to 5. But this method requires the length of the vector. You have to know the length of the vector beforehand. Otherwise, how do you access all the elements starting at index I? Let us say you want to access elements starting at index I till the last element. You have to know the size, otherwise you won't be able to access. So for this, there is a shortcut notation in Matlab. If you want to access all the elements starting from 2, you write 2, comma, colon. So you can simply write 2, colon. Two comma colon. Okay, we'll see this when we discuss matrices. We'll discuss all these things, right? This how to access all the elements from right. So I hope you can access like this. It is 2 2, right? 2 2. Oh, this is column and this is like matrix notation. This won't work here. Okay, we'll see this. No issue. So now we'll see what are the different operations that can be performed on these vectors. Now suppose we have a vector A, right? Now you want to multiply this vector with some element. Let us say a scalar element. Can we perform this scalar operations? Yes, we can perform scalar operations. Now let us take C equals to 5. Now you see C is a scalar, A is a vector, row vector. Now if you want to multiply or add C to A plus C, what happens? You see A plus C. What happened? You see it is 1 2 3 4 5. Now what is the value of C? 5. 5 was added to every element in C. So now if you apply this addition operation on a vector and a single element, what happens? The value C will be added to every element of A. So the same thing happens when you perform A minus C, when you perform A by C, right? When you multiply A with C, what happens? The element C will be multiplied with every element of A. So this is the operation between vector and scalar. Are we clear? This is the operation between vector and scalar. Now let us define one more vector, row vector. Let us say 2 3 4 5. No need of commas again. 2 3 4 5 6. 5 elements. Yes. Okay, this is not correct. There is one more bracket here. So D is a row vector of size 5 elements. A is also a row vector with size 5 elements. Now you want to perform something on this A and B. Now what happens when you perform A plus B? What happens if you perform A plus B? What happened? What happened when you performed A plus B? Every element of A was multiplied with every element of D, right? So therefore, the size of A, how many elements are there in A? 5 elements. How many elements are there in D? 5 elements. So therefore, the output is 25 elements. This is the first element of A is multiplied with all the elements of D. First element of A is what? 1. 1 is multiplied with all the elements of D. Then you got this result. Next 2 is multiplied with all the elements of, not multiplied, this is addition. 2 is added to all the elements of D. You got second row and so on. So what we got is, it is like you are adding every element of A to every element of D. Same thing you will get. A minus D you do, same thing you will get, right? What is this? A minus D. Okay, this A minus D, where is this? D is this one. A plus D. Okay, A plus B. Oh, I did A plus B. Yes. A plus B I should do. A plus D. Yes, A plus D. You see? So this is like adding two vectors. Earlier, it was some issue because one is row vector and the other one is column vector. That's why this result came. But this is the vector operation. This is vector subtraction, this is vector addition. Similarly, you can perform vector multiplication, A star D, right? Okay, A star D. Now, it is not possible to multiply A and D because both are row vectors, right? Its size is 1 by 5, its size is 1 by 5. So, therefore, this multiplication is not possible. Incorrect dimensions for matrix multiplication, right? But addition and subtraction, this is like vector addition and vector subtraction. So, this is possible now, right? Now, we will see a few other operations. So, addition we have seen, subtraction we have seen, multiplication we have seen. We have seen addition, subtraction, multiplication between vector, scalar, and then addition and subtraction between vector and vector, right? Now, suppose you want to transpose a vector. What is A? Let us see. What is A? A is a row vector. Now you want to transpose. How to transpose? Simply write this symbol. This will transpose. You see, A was transposed into a column vector. Is it okay? A was transposed into a column vector. Similarly, you can perform other operations such as if you want dot product between two vectors, right? You can perform. Now earlier A star B, what is A star B? No, A is what? A is a column vector, B is a row vector. B is what? Column vector. D is what? D is a row vector. Now A star D, is it possible? It's not possible because due to incorrect dimension. Now you want to multiply every element. Suppose let us say I want to multiply 1 with 2, 2 with 3, 3 with 4. This kind of element wise multiplication I want to perform. Like dot product. I want to perform dot product between A and D. But here it was giving an error saying that multiplication due to incorrect dimensions. Now how to perform this dot product? So for that matrix supports something called dot. For dot product it has an inbuilt operation dot. Dot product between A comma D. You can give A comma D. Now run it. This is the dot product. You see, 1 times 2, 2 times 3, 3 times 4, 4 times 5, 5 times 6, and the result is 70. So this was the default built-in function for performing this dot product between these two vectors, which was not possible if you use simple multiplication operator. It was throwing an error saying that incorrect dimensions. So this was about these vectors, creating a row vector, creating a column vector, performing operations between scalar and vector, vector and vector, dot product between two vectors. All these things we have discussed. Now let us move on to creating matrices. Let me clear everything. CLC, let me clear workspace also. I have cleared everything. Now let us focus on creating matrix. Now how to create a matrix? Creating a matrix is based on the discussion we have done so far. Now how to create a row vector? Simply write numbers enclosed in square brackets. How to write a row vector? Simply write numbers in a square brackets, right? This we have discussed. How to create a column vector? Simply write numbers, but they should be separated by semicolon. They should be separated by semicolon. So these two definitions will tell us how to create a matrix. Now you see here, this column, what is the effect of column? When you use this column, it will go to the next line, right? That's what happening. So the same thing. Now you want a matrix, multiple rows, multiple columns. How to extend? The same idea. Let us create a matrix A. How to create? Now let us say 3 by 3 matrix you want to create. How to create? 1, 2, 3. This is first row. I am going to next row. So that's why I give column, semicolon. Next row. What is next row? I will give 4, 5, 6. I will go to next row. So I use semicolon. 7, 8, 9. Right? Now let us create this. What happened? You see? You can see the output. in a matrix format. Can you see? This is a matrix with 3 rows and 3 elements. Now the same thing can be extended. How to access an element? Let us say you want to access the 5. How to access this element? You can simply give row number and column number. What is the row number? 2. Column number? 2. Row number and 2. Column number is 2. Let me run. Yeah. Let me create one more matrix with 5 rows, 5 columns. 1, 2, 3, 4, 5. Semicolon. 2, 3, 4, 5, 6. Semicolon. 3, 4, 5, 6, 7. Semicolon. 4, 5, 6, 7, 8. 5, 6, 7, 8, 9. 9. And they should be enclosed in the square brackets, obviously. So now we have created a 5 by 5 matrix. Let us say you want to access this element. How to access this element? That is 4th row. Let us say I want to access this element. So it is 4th row, third column, right? This will give you the 4th row, 3rd column, this element. Now similarly, you want to access a part of this matrix. How to access a part of the matrix? Again same, suppose you want to access this part of the matrix, this 3 by 3 matrix. 2, 3, 4, 3, 4, 5, 4, 5, 6. This subpart, this submatrix you want to access. How to access? This is B, right? Now how to access? What are the row numbers? What are the row numbers and what are the column numbers? Row numbers are first 3 row numbers. So we give 1, 2, 3. Right? These are row numbers. Then what are the column numbers? I want these 2 to 4 column numbers. So I'll give 2, 4 and I'll write. I'll enter. Now you see what is the result? It is 2, 3, 4. This is the 2, 3, 4. 3, 4, 5. 4, 5, 6. That's why I have given 2, 3, 4. 3, 4, 5. So you see 2, 3, 4 means first row, second row, this and this one and this one. That means first 3 rows. Columns are second row, third row, fourth, second column, third column, and fourth column. That's why I given 1, 2, 3, 2 to 4. Is it okay? Now, if you are done with this, the same idea can be extended for other things. Now, let us say I want part of the matrix, but I want to access this first 2 rows. I want to access first 2 rows. So, how will you write? Will you write B of first 2 rows means what? 1, 2. Now, how to write columns now? Columns will you write 1 to 5? 1 to 5? Yeah, this will give the result. But this requires the length of the, means the number of columns in the matrix. Beforehand, you have to know how many columns are there. Right? You want to access all the elements in first 2 rows. That's all. You don't know how many columns are there, let us say. Now you won't be able to use this because you don't know the number of columns. So for those kind of operations, Matlab has some shortcut notations. What is that? Suppose you want to access first 2 rows. You write 1, 2, and you want to access all the elements in these 2 rows. So you simply write column. This column symbol, this is not semicolon, column. So that means all the elements. Now you write B. What is this output of this one? B1 to column. So this will give all the elements in first 2 rows. Similarly, you want to access first elements in first 2 columns. All the elements in first 2 columns. How will you write? You write first argument should be column and second argument should be 1 to 2. So this will give you all the elements in first 2 columns, right? So this way you can access part of the matrix, right? Part of the matrix, some rows of the matrix, some columns of a matrix, you can easily access without knowing how many rows were there, how many columns are there, all these things. Right, so this is accessing an individual element, accessing a part of the matrix, accessing specific rows of the matrix, accessing specific columns of the matrix. Now similarly, if you want to delete something from the row, something from the matrix, let us say you want to delete some row from the matrix. What is there in our B? B contains 5 by 5. Now let us say you want to delete the first You want to delete the last column, let us say, or you want to delete the last row. First, let us delete the last column. Now, how to delete last column? You go to B. First, access the last column. Now, how to access the last column? Tell me. Last column means all the elements in the last column. So, all the row elements. So, row should be everything, and all the elements in the last column. So, 5, right? B comma 5. Now, I want to delete this last column. So, I simply give this empty. Now, you see what happened to B? What happened to B? This got deleted. The last column was deleted, and the first 4 columns were remaining. You see, now B got affected also. The last column was deleted. Now, similarly, you want to delete the last row. How to delete last row? How to delete last row? That means you want to delete all the elements, all the column elements, right? All the column elements. So it was similar to this one. Now I want to delete the row. That means what is the row? 4th row I want to delete, and I want to delete all the elements in this. So this is the row. That means you want to delete everything in this row. You want to delete everything in this row. So you write empty. Now you see. So this is B 1, 2, 3, 4. This was not deleted. It is not deleted. So it is. You want to delete the same way we can delete actually. Here what we deleted the last column, 5th column we deleted. Now similarly I want to delete. So when we deleted this one, how many rows were there? 1, 2, 3, 4, 5. Yeah, it was deleted. You see, earlier there were 5 rows. Now it was deleted to 4 rows. I was confused, saying that, thinking that 4 rows were there. So 5 rows were there. The last row, 4th row was deleted. 4th row means what? 4, 5, 6, 7 was deleted. I deleted 4th row. That's why this was deleted. 4, 5, 6, 7. Right? It is alright. It is working. Yeah. So now we have seen how to delete a row, how to delete a column also. Any row you can delete, not necessarily the last row. You can delete any intermediate row, you can delete any intermediate column also. Now we'll try to perform some operations on this matrix. Now we have a matrix B which is 4 by 4. Now let us delete one more row and column so that it will be 3 by 3 because A is 3 by 3. So let us make it B is 4 by 4, right? We'll delete one more row and column from this one. So last I will delete 4 comma. So I will delete this one. So what I am deleting? I am deleting. What is this? B 1, 2, 3, 4. 1, 2, 3, 4. 4 by 4 is there, right? When calling a function indexing, use parentheses. Okay, this one. Yeah, we should use this one actually. B of 4 comma column equals to empty. Actually, I was confused with Python. I use Python also. That's why in Matlab we use these brackets, whereas in Python we use square brackets. That's why I was confused. Now you see, the last row was deleted. Now let us delete the last column also. So we'll write simply. We'll write here 4. Now you see, B is 3 by 3 matrix. A is a 3 by 3 matrix. Now let us try to perform some operations on this matrix A plus B. What it will give? It is simple. Matrix addition, right? 1 plus 1, 2 element by element addition. That is what we call matrix addition, right? Matrix addition was performed. Similarly, A minus B, it is simple matrix subtraction, right? Now let us perform A multiplied with B. What happens? We'll see. It is matrix multiplication. This is also good, right? It is 3 by 3, 3 by 3. So the result will be 3 by 3. So this is matrix multiplication, right? So everything okay. Now similarly, so these are operations between matrices, two matrices. Now let us say, let us define some variable c equals to 5. Now the same thing if you perform between a matrix and scalar, now what happens? A plus c. What happens? The element c will be added to every element of a. Is it okay? Similarly, a by c. Element c will be, so every element of a will be divided with c. Same thing, a minus c. All these operations you can perform. This is operation between matrix and scalar. Now similarly, now suppose you want to perform, you want to transpose a matrix. We have a matrix, you want to transpose. How to transpose? What is A? You see, A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Simply transpose using the same notion. This is A transpose. Right? Similarly, you want to perform determinant of a matrix. Inbuilt function exists for finding determinant. Simply write det of A. This is the determinant. Similarly, you want to perform inverse of A. You want to find inverse matrix of A. This is the inverse matrix of A. Right? All these operations can be performed. Right? Matlab supports all these operations. Okay. So all these things are good. We are able to perform determinants, inverse, matrix multiplication, scalar operations on matrices, addition and subtractions, transposes, all these things we are able to do. In addition, we can do concatenate. We can concatenate matrices also. That means what is A? A is this one. What is B? This one. Now let us try to concatenate A with B. How to concatenate? Let us create a matrix D. I want to concatenate A and B. Let us say I want to concatenate A and B horizontally. That means I want the output as 1, 2, 3, 1, 2, 3. That is first row. Second row is 4, 5, 6, 2, 3, 4. Third row is 7, 8, 9, 3, 4, 5. Then what we have to do is you write everything in these square brackets. That's all. A by B. What is this now? You see, this is the concatenation. Horizontally you are concatenating. Now you want to concatenate vertically. That means you want the number of rows to be 6. Earlier the number of rows is 3, columns was 6. Now you want the number of rows to be 6 and columns to be remain same, means 3. Now how to concatenate that way? This is also simple. Again use the same idea, A, B, but it should be separated by a semicolon. Now you see the result. It contains 3 columns but 6 rows. It is called vertical concatenation. So all these operations can be performed on matrices. Now the same idea can be extended to higher dimensional vectors such as 3 by 3, 3 by 3 matrices. You want to create 3 by 3 matrix. I hope now you are in a position to create 3 by 3 matrix. Let me create if you want. So now you will have multiple rows, vectors and dimensions also. So this way you can create higher dimension vectors, higher dimension matrices, right? Okay, now in addition, okay, so I will not go into this creating higher dimensional matrices because it is straightforward. If you want me to create, you can create. Let me create 1, 2, 3, 4, right? This is one matrix. 2, 3, 4, 5. This is one matrix. You see here? Oh, this was okay. Here I have to use one more thing. So this is concatenation actually. Okay, no issue. Okay. So in addition, Matlab supports many built-in functions to create many useful matrices. Let us say you want to create a matrix of all zeros. You give like this, zeros of 4. What it will give? It will create a matrix with all zeros. Can you see the output? All zeros matrix. Similarly, you want to create matrix of ones. You create matrix of ones. So if you give one input, it was taking a square matrix. So if you want to create a rectangular matrix, then you give two inputs. Let us say 4 by 3. Let us say 4 by 5. You give 4 by 5, you are creating a rectangular matrix. If you give a single input parameter, single argument, it will create a square matrix. If you give two inputs, then you can create these rectangular matrices. So similarly, if you want to create an identity matrix, right, you can create using this one, I. So you see, we are creating a identity matrix, 5 by 5 identity matrix using this simple statement I, right? Similarly, if you want to create a random matrix, a matrix with random values, you simply use this rand. If you give rand of 5, you see what happens? You will get 5 by 5 matrix, right? If you give rand of 2 arguments, then you can create a rectangular matrix, 4 by 3. You can create a rectangular matrix. All the, remember here you see all the values are between 0 and 1. So this is about matrices. So I hope we have spent enough time on this creating matrices and so on. So now let us move on to the other topics. So let us go to other topics. So first, what we discuss is, we discuss something known as M files. So far in our discussion, we use this command window. We entered some commands and straight away they got executed, right? By simply clicking on enter, they got executed. Because Matlab was an interpreted language, so we were able to perform all these operations on the command window itself. So in addition to this commands, Matlab supports scripts also. That means you can write something in a file, you can run that file also. So basically Matlab supports two types of M files. Right? So the first type of M files is called function files. And the second type of M files are called scripts. So there are two types. There are basically two types of M files. First one is scripts. Second one is functions. Now what is the difference between the scripts and functions? So for scripts, script is a M file. Basically it is M file. M file means what? Nothing but it is a file, that's all, Matlab file. So script is a Matlab file which does not take any inputs. It does not take any inputs. So it does not require any inputs and it does not return anything. This is called script M file. Now coming to function, as you know, function is an M file which takes some arguments, right? Which may or may not take some argument. That means it can take some argument and it can return something. It can produce some output, return some output. So this is the basic difference between script and function. Both are M files, both are Matlab files only, right? But the script, it does not require any input and it does not produce anything. Whereas function, sometimes it takes arguments, it requires arguments and it returns something also sometimes. So this is the difference between script and function. Now the question is how to create a script. As you see from this live editor, Matlab is an interactive environment. That means here you see, you can directly go and click this new script. It will create a script. So you will get an environment like this, right? Here you can write your code and you can run your code using this run command. Simply click on run, you will get this one. So this is one way. this is using this interactive button using mouse. Click on this new script, you will get a new script. Now the other way to open a script is simply write edit in your command window. Simply write edit. Now it will open a script for you. So these are the two basic ways. Either you can write edit in your command window, or you can directly click on, let me close this one. Either you can directly click on new script here. Under home tab, there is a button called new script. So both are okay. Now let us create some function, some script, and we will try to run this script now. Now we will slowly move from these commands to scripts now, right? Okay, so let us create a script, new script. Let me clear this command window now. Okay, now in order to use this script, let us use the functionalities of control statements and for loops, right? So this Matlab supports these decision statements. If else it supports, if else if it supports for loop. So it supports looping statements, decision statements, all these statements it supports. Now let me demonstrate some of the things here. So let us start with this if. Let us say, let us take some number as input, a equals to 11. So we will see how to use if statement in Matlab. Now let us say using script. Okay, let me write if. So we have to use this keyword called if followed by the condition. So let us say I want to perform mod operation on a. So there is an inbuilt function mod a comma 2. If the output, that means if the remainder is 0, then I want to print. I want to print what? I want to print it as even. Else I want to print odd. So in Matlab, there is no need to use these braces. Instead, what we do is all the body of if will be enclosed between something known as end. So you see here, if and end should be aligned so that this statement will be part of this if loop. Now I want to print as even or odd. So if you want to print something, you use the function called display. Display. This is for disp stands for display. Display. Right? Now let us run. Now you see the other should be else. So this Matlab supports else statement also. So this is else. So end should be here. If, else, and end. Now before running the script, we have to save the script. So let us save the script using this save button. So let us save it as if loop, if statement, if and else. Okay, if else statement. Now okay, our script is ready, right? You want to run the script. It is simple again. Simply click on run. Go here and click run. You see, this is the file name that you are running. What is the script name? Your name is if else. Now you see, when it was running the output, you see you are simply displaying whether it is even or odd. So it was displayed odd. But in addition, it was displaying the value of a also, right? So in order to suppress the output, what we use? We use semicolon. Now let us run again. Now let me clear this command window first. Now let me run again. Okay, let me enlarge the command window. Now let me run again. You see, it was simply printing odd. I hope it is clear. Let me maximize so that you can see my screen. Right? You see, it was simply displaying even or odd. So similarly, Matlab supports else if statement also. So that means here if it is not 0, if it is odd, then you want to check something else. Let us say mod of a by mod of a with 3, whether it is divisible by 3 or not, you want to check. If it is divisible by 3, you simply display odd and divisible by 3. Else what we write? Odd but not divisible by 3. Right? So let us give here what something called 15. Let me give 15. Now let me run again. Let me save it. Now let me run it first. Then I want to show you something. Now let me run it. See what we got? We got odd but not divisible by 3. Why you got this one odd but not divisible by 3? It should be odd and divisible by 3. Because while running it was not saved. So that's why you got this output. So let me run again, then you will get the correct output. Odd but not divisible by 3. Let me save this one. I used control save. I think it is clear, right only. Odd and divisible by 3. It is 15. It is not even. Okay, I have to use this one. The statement checking. Yeah, right. So incorrect use of the operator. This issue 9.4 as if mod by 3. Else if mod of a comma 3. So let me odd and divisible by 3. Some issue in running the script, but now you see you got the correct value, odd and divisible by 3. So this way we can create scripts, right? You see this script does not require any. Do you think it requires some arguments? No, it doesn't require any arguments. Do you think it requires, do you think it has to output something? No, no need to return something, right? That's why it is called script M file, script Matlab file. Okay, now I take this opportunity. Okay, let me see the time if it is 45 minutes. Okay, for nearly 43 minutes. So I'll stop here and we'll discuss the other concepts and other fundamentals in our next session.